Welcome to another deep dive. Today, we're going to be cracking open a stack of fresh research papers on AI and emerging tech. And trust me, it's a fast-moving landscape. We've got everything from, AI governance and security to robotics that seem almost like science fiction to large language models that are getting more powerful by the day.
Yeah. It's not just the pace of the progress that's remarkable, it's the sheer scope. We're seeing all these different fields converging in some really interesting ways, economics, social science, philosophy. It's all kind of intertwined with the development of these technologies.
It really does make you wonder, are we kind of on the cusp of a future where algorithms design our cities, robots learn from our dreams, and AI is grappling with complex ethical dilemmas?
Hmm.
Let's dive into the research and find out, huh?
I think a good place to start might be with AI governance and ethics. There's one paper that really caught my eye, a blockchain-enabled approach to cross-border compliance and trust. It proposes a pretty ambitious idea using blockchain to create a global framework for regulating AI.
A global framework. That's a pretty tall order. What are the potential benefits of using blockchain for something like that?
Well, think about it, right? AI development isn't confined to national borders, right? We need a system that can ensure responsible development and use on a global scale. And, blockchain with its decentralized and, transparent nature could be the key. This paper even outlines potential applications in the financial sector, which is already, starting to grapple with all the implications of, AI-driven decision-making.
So instead of relying on individual countries to regulate AI, we could have a system that's transparent and accessible to everyone. That's a pretty fascinating concept, but I can only imagine the challenges are enormous.
Absolutely. We're talking about harmonizing regulations across, tons of different countries, addressing technical complexities, ensuring data privacy. It's definitely a long-term project, not a quick fix. The paper acknowledges this, outlining a phased deployment strategy that actually stands, the next decade.
A decade-long project. Wow. Shows you the scale of what we're dealing with. Okay. Shifting gears a bit to something that's a little unsettling. There's a paper here called Characterization of Political Polarized Users Attacked by Language Toxicity on Twitter. The title alone's pretty alarming.
What's concerning is the finding that left-leaning users on Twitter receive significantly more toxic replies than other groups. And, the implications for online discourse and, the spread of misinformation are significant.
It's a sobering reminder that social media platforms, for all their potential for connection, can also amplify, negativity and division. It almost seems like the algorithms that are, designed to keep us engaged might be contributing to the problem.
Yeah, you've hit on a crucial point here. This research really highlights the urgent need for more nuanced approaches to content moderation and a deeper understanding of how these AI systems can influence and potentially manipulate human behavior online.
All right, here's a paper that offers a glimmer of hope beyond reward hacking. Causal rewards for large language model alignment. What caught my attention here was this idea of, moving beyond just pattern recognition in AI.
Right. This paper delves into a fundamental challenge with large language models, or LLMs. They're trained on massive data sets, but they can sometimes learn spurious correlations, which leads to things like bias and sycophancy.
So it's not enough for the AI to just learn patterns. It needs deeper understanding of the relationships between things.
Yeah, exactly. The paper proposes using causal inference to address this. So imagine an AI that can not only predict outcomes, but also understand the why behind them. That's a huge step toward building more trustworthy and fair AI systems.
It's like teaching the AI to think more critically, to understand cause and effect. That could have a huge impact on everything from, reducing bias in algorithms to developing AI that can solve complex problems more effectively.
Okay, let's shift gears now and talk about some of the mind-blowing advancements happening in AI and robotics.
Yeah, a great example is the research being done on extrapolation in machine learning. The paper Towards Understanding Extrapolation, a Causal Lens, tackles a pretty fundamental challenge. getting AI to make accurate predictions outside of the range of data that it was trained on.
That sounds like a pretty crucial skill for AI to have, especially if we're talking about, things like self-driving cars or AI that can diagnose diseases. We
Yeah.
need those systems to be able to handle new situations they haven't encountered before.
Yeah, exactly. The paper argues that a causal understanding of the world can significantly improve a model's ability to extrapolate. It's about moving beyond simple pattern recognition and toward a deeper understanding of how different variables interact. So instead of just memorizing patterns, the AI needs to understand the underlying relationships that govern those patterns. That's fascinating. Okay, now for a paper that's particularly exciting for me. Interpretable droplet digital PCR assay for trustworthy molecular diagnostics. I've always been fascinated by the potential of AI in healthcare.
Yeah, this research showcases the power of combining neural networks and large language models to automate and enhance molecular quantification in diagnostics. So imagine like a system that can not only analyze complex medical images, but also explain its reasoning in a way that doctors can understand and trust.
That's a key point, isn't it? Trust and transparency. We don't want AI making, life or death medical decisions in a black box. We need to understand how it's arriving at its conclusions.
Absolutely. Transparency builds trust, and trust is essential for the widespread adoption of AI in healthcare. This technology has the potential to revolutionize diagnostics, disease research, and personalized medicine, but only if we can ensure that it's both accurate and understandable.
Here's a paper that sounds like it's straight out of science fiction. Making your dreams a reality. Decoding the dreams into a coherent video story from fMRI signals. Are they actually trying to film our dreams?
Well, not quite as straightforward as filming a movie inside someone's head, but it is a fascinating step in that direction. Researchers are using fMRI data to capture brain activity during dreaming and then using AI to translate those signals into visual narratives.
So while we might not be able to watch a full-blown dream movie just yet, it's still a pretty mind-blowing concept. What are the potential applications of this kind of technology?
Oh, the possibilities are vast. Imagine being able to understand and treat sleep disorders more effectively, or using dream content to, enhance creativity and problem solving.
Yeah.
It could even lead to more immersive and personalized virtual reality experiences. This research opens a window into consciousness and the inner workings of the brain, which is incredibly exciting.
Really blurs the line between, science fiction and reality. Speaking of blurring lines, how about robot surgeons? The paper Scaling Up Self-Supervised Learning for Improved Surgical Foundation Models describes something called Surgeonette XL, an AI model trained on millions of surgical videos.
Surgeonette XL highlights how AI can, augment human expertise rather than replacing it entirely. So imagine like a system that can provide real-time guidance during surgery,
Yeah.
helping surgeons make more precise and informed decisions.
So it's like having an incredibly knowledgeable assistant in the operating room, able to analyze the situation and offer suggestions based on a vast database of surgical experience.
Yeah, exactly. And this technology has the potential to improve surgical outcomes, reduce complications, and make complex procedures safer and more efficient.
From analyzing dreams to assisting surgeons, the potential of AI seems almost limitless. But let's not forget about how we interact with AI in our everyday lives. The paper MOE, Optimizing Collaborative Inference for Edge Large Language Models, caught my eye because it deals with something called edge computing.
Yep.
Can you explain what that is and why it's important for AI?
Yeah, edge computing is all about bringing computation closer to the source of the data rather than relying on centralized cloud servers. Think about your smartphone running powerful AI applications without needing a constant internet connection.
Yeah.
That's the power of edge computing.
So it's about speed, efficiency, and making AI accessible anywhere, anytime. But hold on, wouldn't distributing processing across multiple devices create new complexities? How does this MOE framework handle that?
That's a great question. The challenge is to balance the workload effectively, ensuring smooth communication and coordination, between all the different devices involved. Moiki uses a collaborative approach where multiple edge servers work together to optimize LLM inference.
So it's like a team of mini brains working together to process information quickly and efficiently. That's pretty ingenious. Okay, moving from the microscopic world of edge devices to the sprawling landscapes of our cities. There's a paper here called "Predicting Air Temperature from Volumetric Urban Morphology with Machine Learning." What's that all about?
It's about using AI to create more sustainable and livable urban environments. This research describes a method for predicting air temperature in cities based on the shape and arrangement of buildings.
So city planners could use this to optimize building design and placement, potentially reducing the urban heat island effect.
Yeah, exactly. By understanding how urban design impacts temperature, we can make our cities more resilient to climate change.
Yeah.
This technology could lead to cooler, more comfortable, and more energy-efficient urban spaces. It shows how AI can be a powerful tool for tackling real-world problems that affect us all.
Now, for a paper that's close to my heart, evaluating Gen AI for simplifying texts for education. I love the idea of making knowledge more accessible.
Yeah, this research explores the potential of large language models to simplify educational texts, making them more accessible to students with varying reading levels. Imagine a textbook that can automatically adjust its complexity based on the individual student's needs.
That could be a game changer for education, especially for students who struggle with reading comprehension. But I imagine there are some challenges in making sure the simplified text is accurate, consistent, and doesn't lose any crucial information.
You're absolutely right. The paper emphasizes the need for rigorous evaluation to ensure these simplification systems are both effective and reliable. We need to make sure the AI is simplifying the language without distorting the meaning or leaving out important details.
It's a delicate balance, but the potential benefits are enormous. Okay, for our last paper in this segment, let's delve into a different way of thinking about assistive AI. The paper "Learning to Assist Humans Without Inferring Rewards" caught my attention because it challenges traditional approaches to AI assistance.
Right. Traditional assistive AI often relies on the AI trying to infer human intentions, which can be, really complex and prone to errors.
So it's like the AI is constantly trying to guess what the human wants, which can lead to misunderstandings and frustration. What's the alternative proposed in this paper?
This paper proposes a method based on the concept of empowerment. Instead of trying to guess what the human wants, the AI focuses on maximizing the influence of human actions.
So it's about shifting the focus from intention to capability. The AI isn't trying to read the human's mind. It's trying to provide the tools and support to help them achieve their goals more effectively.
Precisely. It's a subtle but important shift in perspective, and it could lead to more intuitive and effective assistive AI systems. Imagine a future where AI seamlessly integrates into our lives, not as a mind reader, but as a powerful partner in achieving our goals.
That's a future I can get behind. We've covered a lot of ground in this first segment, from global AI governance to AI that can help us understand our dreams. And we're just getting started. Join us in the next segment as we continue our deep dive into the latest breakthroughs in AI and emerging tech. Welcome back to our deep dive into the world of AI and emerging tech. It's really mind-boggling to think about how rapidly these fields are advancing and the sheer volume of groundbreaking research coming out all the time.
It's truly a testament to human ingenuity and the relentless pursuit of knowledge. And as these technologies continue to evolve, it's more important than ever to stay informed and engaged.
Absolutely. So let's jump right back into our stack of research papers. This next one really caught my eye because it seems to be tackling a critical challenge in medical imaging. Making those powerful AI models more efficient for real-world healthcare settings.
You talk about the paper PFOMID, Parameter-Efficient Fine-Tuning of Multimodal Large Language Models for Medical Imaging. It's a mouthful, but the core idea is fascinating.
That's the one. It sounds like they're finding ways to optimize these complex models so they can be used in hospitals and clinics without without needing a supercomputer.
Exactly. These multimodal large language models are capable of processing both text and images, which you know, makes them incredibly valuable for medical applications.
Mm.
Imagine an AI that can uh, analyze a patient's medical records, scan their X-rays, and then provide a comprehensive diagnosis and treatment plan.
That sounds like the future of medicine. But as you said earlier, these models require a ton of data and computing power. How are they making them more practical for everyday use?
That's where parameter efficient fine-tuning comes in. It's a technique for optimizing these models so they can be trained and deployed with fewer resources. And the paper shows how they tested this framework on two important medical tasks: visual question answering and medical report generation.
So the AI can not only analyze images but also understand and respond to complex questions about them. That's incredible. What were the results like?
They were quite promising, showing significant improvements compared to previous approaches. This means we're getting closer to a future where AI can play a more active role in healthcare, assisting doctors and improving patient care.
That's really encouraging to hear. It seems like AI is becoming more and more integrated into healthcare in a meaningful way. Okay, shifting gears now to a paper that takes us into the world of software development, meaning typed programming, language level abstractions, and runtime for Gen AI applications. I have to admit, the title is a bit intimidating.
Yeah, it sounds complex, but the underlying idea is actually quite elegant. They're proposing a new way of programming that leverages the power of AI to make software development easier and more intuitive.
So instead of writing traditional code, you're working with meaning. That sounds almost philosophical.
In a way, it is. The idea is to harness the semantic richness of conventional code.
Hmm.
Think about all the information that's already embedded in the structure and syntax of a program. It's not just about the lines in text. It's about the logic, the relationships between different parts of the code.
I see what you mean. There's a whole layer of meaning behind the code itself. So how does this new programming paradigm tap into that meaning?
They've developed a system that can, extract this semantic information and use it to guide the integration of, AI components. It's like the AI is understanding the intent behind the code rather than just the raw instructions.
So it's like the AI is acting as a partner in the development process, helping to translate human ideas into functional software.
That's a great way to put it. And this approach could make it much easier for developers to create sophisticated AI-powered applications without needing to be AI experts themselves.
That's a game changer. It could really democratize AI development and open up a whole new world of possibilities. Now let's talk about a challenge that's plagued AI for a while: training models on limited data. The paper enhancing few-shot image classification through learnable multi-scale embedding and attention mechanisms tackles this head-on.
The few shot scenario is a tough one for AI. It's like trying to teach a child to recognize different breeds of dogs after showing them only a handful of pictures.
Mm.
They need to learn to generalize from very limited information.
Exactly. So how does this paper approach this challenge?
They've developed a method that combines multi-scale embedding and attention mechanisms. Essentially, the model learns to extract and focus on the most relevant features from the images, even when there are only a few examples to learn from.
It's like the AI is developing a keen eye for detail, learning to spot, subtle differences that might be missed by a less sophisticated model.
Precisely. And the results are impressive. They've shown that this approach significantly improves few-shot image classification accuracy, meaning we can potentially build AI models that are more adaptable and can learn new concepts quickly.
That's exciting. It opens up the possibility of using AI in situations where data is scarce, which is often the case in specialized fields or niche applications. Okay, let's dive back into the world of education with a paper that focuses on a different kind of data challenge. Boosting short text classification with multi-source information exploration and dual-level contrastive learning short texts. Are we talking about tweets and social media posts?
You got it. Short texts are notoriously difficult for AI to analyze because they lack the context and richness of longer documents, like trying to decipher a cryptic message with only a few words to go on.
I can see how that would be tricky. It's it's hard to get a clear sense of someone's intent or meaning from just a snippet of text. So how does this paper approach the challenge of short text classification?
They've come up with a multifaceted approach. First, they explore different sources of information beyond, just the raw text. This could include things like, statistical features, linguistic patterns, and even external knowledge bases.
So they're essentially enriching the limited data with additional context, giving the AI more to work with.
Exactly. And on top of that, they employ a technique called dual-level contrastive learning. This helps the model learn more robust representations by, contrasting positive and negative examples.
It's like showing the AI both good and bad examples of short text classification, helping it to learn the subtle distinctions between different categories.
That's a great analogy, and the results speak for themselves. They've demonstrated significant improvements in short text classification accuracy, which could have implications for everything from sentiment analysis to spam detection.
That's fascinating. It seems like AI is getting better and better at understanding the nuances of human language, even in its most condensed forms. Okay, prepare to enter the matrix with this next paper. Creating virtual environments with 3D Gaussian splatting, a comparative study, Gaussian splatting. It sounds like something straight out of a science fiction movie.
It's a fascinating technique for creating realistic and immersive virtual environments. Essentially, it involves representing 3D objects as a collection of Gaussian functions. Those bell-shaped curves you might remember from statistics class.
Oh, yes, vaguely ringing a bell. So how do those bell curves translate into a virtual world?
Imagine, painting a virtual world with mathematical brushstrokes.
Yeah.
Each Gaussian function acts like a dab of paint, contributing to the overall shape and appearance of the objects in the scene.
Yeah.
By combining these Gaussian functions, you can create incredibly detailed and visually appealing 3D environments.
That's amazing. It sounds like a blend of art and science using mathematical tools to create a virtual world that feels real.
Exactly. And this paper explores, different approaches to 3D Gaussian splatting, comparing their, strengths and limitations for creating virtual environments.
It seems like virtual reality is getting, more and more realistic by the day, blurring the lines between the physical and digital worlds. Okay, time for a few more exciting advancements before we wrap up this segment. Let's dive back into the world of surgical AI with the paper Scaling Up Self-Supervised Learning for Improved Surgical Foundation Models. This is where SurgeonNet XL comes in, right?
You're absolutely right. We touched on SurgeonNet XL earlier, but let's take a closer look. This is a truly remarkable AI model that's been trained on millions of surgical videos to develop a deep, understanding of surgical procedures. It's like having a digital understudy that's, observed countless hours of surgery and learned from the best.
It sounds like the ultimate surgical training tool, but what can SurgeonNet XL actually do in practice? What tasks is it capable of performing?
Well, SurgeonNet XL has achieved state-of-the-art performance across a wide range of surgical tasks, including semantic segmentation, phase recognition, and critical view of safety classification.
Yeah.
These are complex tasks that require a nuanced understanding of surgical procedures.
Break those down for me. What do those tasks actually involve?
Imagine you're watching a surgical video. Semantic segmentation is, like labeling each pixel in the video to identify different anatomical structures, the heart, the lungs, the blood vessels. Phase recognition is about understanding the different stages of the surgical procedure, the incision, the dissection, the suturing. And critical view of safety classification is, about ensuring that the surgeon has a clear view of critical structures to avoid accidental damage.
Wow. That's a lot to process. It's incredible to think that an AI model can perform these, tasks with such accuracy.
It is, and the success of SearchNet XL really highlights the incredible potential of AI to revolutionize
Right.
surgery. It's not about replacing surgeons. It's about empowering them with real-time guidance and support, making surgery safer and more efficient.
It's like having a co-pilot in the operating room, a second set of eyes that can analyze the situation, provide insights, and help the surgeon make the best possible decisions.
That's a perfect analogy. Now let's shift gears to a more technical topic, the paper ADA-FV, Accelerating VLMs with Self-Adaptive Cross-Modality Attention Mixture. This one deals with vision language models, or VLMs, a powerful type of AI that can process both visual and textual information.
VLMs sound incredibly versatile. What kind of applications are they used for?
Oh, you name it. Image captioning, visual question answering, even generating descriptions of videos. VLMs are like the ultimate multimedia processors, seamlessly blending information from different sources.
But as we've discussed, these powerful models can be computationally demanding. Is that what this paper is addressing?
You got it. A2V is a new approach that focuses on making VLMs faster and more efficient, specifically by reducing the number of visual tokens that need to be processed.
Visual tokens. Explain that to me like I'm 5.
Imagine breaking down an image into a grid of smaller squares, like a mosaic. Each square represents a visual token. A2V uses a clever mechanism to selectively discard less informative tokens, kind of like decluttering the visual information without sacrificing the model's overall understanding.
So it's like the AI is learning to focus on the most important parts of the image, filtering out the noise and distractions.
That's a great way to put it. And this approach leads to significant speed improvements without compromising the model's ability to understand and process visual information. That's impressive. It seems like we're constantly finding new ways to optimize these powerful AI models, making them more accessible and practical for real-world use. Okay, last one for this segment, and it sounds a bit like a spy thriller. Complex VADI detecting interaction anomalies in video anomalies. Are we talking about rogue robots or something? Not quite, but it does involve identifying unusual or unexpected events in videos, which can be crucial for a variety of applications, from surveillance systems to self-driving cars.
I can see how that would be important. Think about a self-driving car that needs to be able to recognize if a pedestrian is about to jaywalk or if another car is behaving erratically.
Exactly. Complex VADI is a new data set and method specifically designed to detect anomalies that arise from interactions between objects. It's not just about a single object acting strangely. It's about recognizing patterns of behavior that are out of the ordinary.
So the AI is learning to understand not just individual actions, but also the relationships and interactions between different objects.
Precisely. Think about a surveillance system that can detect a suspicious interaction between two individuals, even if neither individual is behaving suspiciously on their own.
That's pretty powerful. It's like the AI is developing a sixth sense, a subtle awareness of the dynamics between different elements in a scene.
Yeah, it's a fascinating area of research, and complex VD is a significant step forward in developing AI systems that can, effectively monitor and respond to, complex real-world situations.
That's a great point. As AI becomes more integrated into our lives, it needs to be able to understand not just individual objects and actions, but also the complex interplay between different elements in the environment.
Absolutely. And that brings us to the end of this segment. Stay tuned for our final segment, where we'll wrap up our deep dive with even more fascinating research and discuss the broader implications of these advancements for the future of AI and technology.
Welcome back to the final part of our deep dive into the latest and greatest in AI and emerging tech. We've explored some truly mind-blowing research so far, from robots learning to feel, to algorithms that can potentially decode our dreams. I'm eager to see what other surprises this stack of papers has in store.
We'll get ready for another whirlwind tour because we've got some fascinating research to unpack, covering everything from the intricacies of the human heart to the complexities of self-driving cars.
Sounds good to me. Let's dive in. This first paper caught my eye because it deals with a topic that's close to home for many of us, heart health. The title is a bit of a mouthful: Learning Hemodynamic Scalar Fields on Coronary Artery Meshes, a benchmark of geometric deep learning models.
It sounds intimidating, but the underlying concept is actually quite straightforward. Researchers are using AI to predict blood flow patterns in coronary arteries.
So doctors could use this to diagnose and treat heart conditions more effectively. That could be a game changer for millions of people.
Exactly. Think of it this way. Imagine being able to create a highly detailed 3D map of a patient's coronary arteries, showing exactly how blood is flowing through them. This could help doctors identify blockages, assess the severity of heart disease, and personalize treatment plans with much greater precision.
It's like giving cardiologists a superpower. They can see inside the heart in a way that was never possible before. What kind of AI models are they using to achieve this?
The paper explores a range of geometric deep learning models,
Yeah.
specifically designed to, work with the complex 3D structures of coronary arteries. These models can analyze the shape and structure of the arteries, taking into account factors like blood pressure and velocity to create a comprehensive picture of blood flow.
It's incredible how AI is being applied to such a wide range of medical challenges.
Yeah.
Okay, from the heart to the open road, this next paper, DrawVLM, driving with graph visual question answering, sounds like it's straight out of a futuristic driving game. Are we talking about self-driving cars that can answer trivia questions while navigating traffic?
Not quite trivia,
Yeah.
but it does involve equipping self-driving cars with a more sophisticated understanding of their surroundings. Imagine a self-driving car that can not only see the road, but also reason about it, answering complex questions about the driving environment.
So instead of just reacting to obstacles, they can actually analyze the scene and make more informed decisions. That sounds like a big step towards, truly autonomous driving.
Exactly. This paper introduces a new task called graph visual question answering, or GraphEQA, specifically for autonomous driving. It involves using graph-structured reasoning to, answer questions about the driving scene. For example, the car might ask itself, is there a pedestrian likely to cross the street in front of me?
Yeah.
Or is that vehicle signaling a lane change?
It's like giving the car a cognitive upgrade, allowing it to think more, strategically about its actions.
Precisely. By combining visual perception with this, higher level of reasoning, self-driving cars can navigate more complex situations, anticipate potential hazards, and make safer and more, efficient driving decisions.
Okay, back to the world of large language models and edge computing. The paper PICE, a semantic-driven progressive inference system for LLMs serving in cloud edge networks, caught my attention because it seems to be addressing a key challenge we discussed earlier. Making these powerful models accessible on devices with limited computing power.
You're right on the mark. This paper tackles the challenge of deploying large language models in cloud edge networks, which essentially means making these powerful AI capabilities available on a wider range of devices, from smartphones to smart home appliances.
So instead of relying on a centralized cloud server to do all the heavy lifting, the processing is distributed across multiple devices.
Exactly. Think of it as Teamwork PyC uses a progressive inference paradigm, which breaks down the task of generating text into two stages. First, a large language model in the cloud creates a rough draft, and then smaller, more efficient models on edge devices refine and expand on that draft.
It's like having a team of writers working on a document. The cloud-based model provides the initial outline, and the edge devices fill in the details. That's a clever way to balance the workload and make the most of available resources. What are some of the potential benefits of this approach?
Well, by distributing the processing in this way, you can significantly improve throughput and reduce latency, which means faster and more responsive AI applications, even on devices with limited computing power.
That's fantastic. It opens up a whole new world of possibilities for AI-powered applications, making them accessible to a much wider audience. Now, for a paper that caught my eye because it combines, AI with a field that's often seen as its opposite, scientific research. The title is "The Artificial Scientist in Transit Machine Learning of Plasma Simulations." I have to admit, I'm intrigued.
This paper highlights how AI is becoming an invaluable tool for scientific discovery. It describes a system for analyzing massive amounts of data generated by plasma simulations, which are used to study phenomena ranging from nuclear fusion to, astrophysics.
I can imagine those simulations generate a ton of data. What's the advantage of using AI to analyze it?
Well, traditional methods for analyzing this, data can be incredibly time-consuming and require a lot of, manual effort. This system uses machine learning to, extract meaningful insights from the data in real time, allowing scientists to make discoveries much faster and more, efficiently.
It's like having an AI assistant that can sift through mountains of, data and highlight the, most interesting findings, freeing up, scientists to focus on the, big picture. That's a game changer for, scientific research.
It truly is. AI is not just changing the way we, live. It's changing the way we understand the universe. Okay, we've got time for a few more quick highlights before we wrap up this deep dive, ready for a rapid-fire round.
Absolutely. Bring it on.
First up, we have navigating gender disparities in communication research leadership, academic recognition, career development, and compensation.
An important topic for sure.
Yep.
What are the, key findings of this research?
This paper examines the, persistent gender gap in communication research. While female authors are, increasingly represented, they still face disadvantages in terms of citations, authorship patterns, and even, salary. It's a sobering reminder that we need to, actively address these systemic biases to create a more equitable research environment.
Absolutely. Shining a light on, these issues is the first step towards creating meaningful change. Okay, what's next on our list?
Next, we have scheduling coflows for minimizing the maximum completion time in heterogeneous parallel networks. This one's a bit, technical, but it essentially deals with finding the most efficient way to schedule complex data processing tasks across different types of, computers and network connections.
So it's about optimizing performance in, large-scale computing systems. That's critical for everything from scientific research to business analytics.
Precisely. And their algorithms significantly outperform existing methods, leading to faster and more, efficient data processing.
Impressive. It's a great example of how, even highly technical research can have a significant impact on, our daily lives. Okay, last but not least, what's our final paper?
Our final highlight is solving infinite player games with player-to-strategy networks. This paper delves into the fascinating world of game theory, specifically studying strategic interactions between a large number of players.
Infinite players. That sounds incredibly complex. What are some real-world examples of these kinds of interactions?
Think about financial markets, online auctions, or even social media platforms. In each case, you have thousands, even millions of individuals making decisions that affect each other.
And this paper uses neural networks to model and understand these complex interactions. That's fascinating.
Exactly. It's a cutting-edge application of AI that could lead to a deeper understanding of human behavior and the dynamics of complex systems.
That's a fantastic way to wrap up our deep dive. We've explored a truly remarkable range of research from the microscopic world of molecules to the vast expanse of the cosmos. It's clear that AI is not just a technological advancement; it's a transformative force that's reshaping every aspect of our world.
And this is just the beginning. As AI continues to evolve, we can expect even more groundbreaking discoveries and innovations that will challenge our assumptions, push the boundaries of human knowledge, and ultimately shape the future of humanity.
It's an exciting time to be alive, and we hope this deep dive has given you a glimpse into the incredible potential of AI and emerging tech. Until next time, stay curious, keep exploring, and remember the future is what we make it.